Hello, this is Mr. Hupp, and I want to go through what I'm going to be checking for in the IPC notebook on Thursday. So let's go through page by page. So on page 11, we should have some data collection here. We collected data about walking, and on page 11, I should see data set 3 glued in, and I should see a description of the motion that we may see in graph 3, and I should also see a properly constructed and labeled graph for data set 3, and then I should also see an insert for data set 5 glued in, and a description of the motion in graph 5 and a properly constructed graph for 5. So you should have complete information for group 3 and group 5 on those pages. On page 12 at the top, we should see notes about dry mix. This is the dependent or responding variable is on the y-axis. The manipulated or independent variable is on the x-axis. There was also a little insert for graphing notes about how to make a graph. And we should have data set 4 glued in there. You should have a graph for data set 4, and you should have a description of what you would see if you were watching something make that motion. On page 13, there was a bit.ly that we went to explore momentum. It's some little carts that you bump together, and I ask you to have one cart moving at 0, or set one cart to 0, and explore different kinds of collisions. What if the red cart was heavier, exactly the same, or lighter than the blue cart, and what kind of collisions would happen there? So some sort of example, or some sort of content there, just a few notes about what you observed. This is the bit.ly right here if you want to go fill that in. So bit.ly/2nt, capital letters, lowercase g, capital Y, the number 0, and a capital M. So that's the bit.ly that'll take you to the physics classroom simulation, and you can make some observations there. So there are some instructions there that we really don't want to mess with right now, but that's what you should do. Just collide some carts, different scenarios, and record your observations. Page 13, insert about problem solving with guests and 4 example problems that we worked in class. So this is how I want you to work math problems for me, and we've started some homework that uses this, so that's what I'm looking for on there. Okay, on page 15, let me make a small adjustment here. We want that to be about right there. Okay, on page 15, we should have 4 quadrants. Draw a line from the top to the bottom and through the middle, left to right. And you should explain these terms and include diagrams demonstrating these terms. The 4 terms we should see on this page are inertia, sliding friction, gravity, and free fall. On page 16, you should have the IPC Unit 2 vocabulary insert, and it has several words on it for this unit. It was kind of a fill-in-the-blank kind of thing. So if you weren't here that day, get the content from someone. On page 17, you should have a we should have an example of some guess problems here. So we did a practice problem about a Hummer, and I have an insert. Oh, what we did here, I remember now. This is where we changed the order of our pages. So we are making notes go on the left and output on the right. Okay, so that's what we need to see. Okay. Then we did a practice problem. On page 18, we also did another practice problem about momentum and a curling stone. So we just worked a couple of problems using the guess format. If you weren't here that day, copy them from someone. Page 19 is an insert about the Unit 2 force notes. So I posted a completed version of this on Canvas. If you did not get that information, go ahead and get on Canvas and find it. It should be posted in the calendar. And then you can complete those notes. So I'm going to be looking that you completed the notes on that page. Page 20, we have a force versus mass lab. And on this page, I should see a procedure, step by step what we did. So we measured the mass on a triple beam balance. We measured the force using a force sensor, and we checked random objects from anywhere from just a few grams to about 600 grams, and we measured the forces that went with those. On that same page, we should have a mass and force data table. So mass should be first, and then force should be second. It should also identify the object. So these would be column headings right here. You should have object, and then you should have force, and then you should, or mass, and then force. Okay? And then you should have a properly labeled and correctly configured graph of force versus mass. You should show a slope calculation. Finding the slope. So it should be rise over run. So it might look like this in your calculation. So it might say slope is equal to rise divided by run, and that's equal to force divided by mass, and that is equal to some numbers, let's say 40 divided by, it would actually be more like 4 divided by 0.4, and that might equal 10. And we know that after some analysis, that should be meters per second squared, okay? And so the slope, what does the slope mean in this graph? We discussed this in class a little bit. Many people discovered this on their own after reviewing the notes. The slope, if you take the force divided by the mass, you get a slope that tells you the acceleration due to gravity, because we use triple beam balances to identify mass, and we were just hanging the weights on the force sensor. So the only thing accelerating those was gravity. You should have a number around 9.8, and I heard numbers that ranged from 3 to about 11. And if you're around 8, 9, 10, or 11, you did really, really good on your graphing. If you got 3, we need to talk. You're probably just counting the squares and ignoring your scales, and that can cause trouble. So that's page 20. And so that'll be what I potentially check. I'll look at pages 11 through 20 on the next notebook check. That'll be on Thursday. So make sure you have things in order by then, and we'll go from there. All right. Thank you very much.